Hey kids, time to do some more review of AAF with one extra objective. So last year we graphed tangent, which remember is just your ratio of your unit circle sine values to cosine values. And then your three reciprocals, the reciprocal of tangent, reciprocal of cosine, and reciprocal of sine. So that's all old news. But we didn't do transformations. So that's the only new objective. So I'm going to very quickly go through the four graphs to remind you, because you've got notes on them from last year and practice. But I do just want to remind you what we want to see in these graphs. Since tangent is a ratio, your vertical asymptotes are going to be wherever your denominator is equal to 0. Your x-intercept is going to be anywhere your numerator is equal to 0. A y-intercept is always plugging in 0 for x. So sine of 0 over cosine of 0 is 0 over 1, which is 0. Your domain is going to be a result of what you kicked out for vertical asymptotes. I mean, what your vertical asymptotes are, kick them out of the domain. Remember, because there's not going to be any holes. It's not like you're going to cancel matching factors. But I do want to show you how sometimes these are written. Your vertical asymptotes are going to be at pi over 2 because cosine of pi over 2 is 0. So is cosine of 3 pi over 2. So is cosine of negative pi over 2. So is cosine of negative 3 pi over 2, and so on and so forth. So sometimes you'll see this written this way. Right? The odd pi over 2s. And then, of course, you just kick the odd pi over 2s out of the domain. I'm going to leave the period and range for a minute. So you need to label your vertical asymptotes, which again would be x equals pi over 2 and so on. And so 3 pi over 2, negative pi over 2, negative 3 pi over 2. And I am graphing from negative 2 pi to 2 pi in these cases. And then my x-intercepts you would have to label, right? Those would be at the pi's. And of course, this one and this one too. Sometimes that's written this way. The x-intercepts are at all the plus and minus pi's with a multiplier in front, and your multiplier is an integer, right? 1, 2, 3, 4, 5 pi, negative 1, negative 2, negative 3, negative 4, negative 5 pi. And then I hope you know tangent. Of course, you know that tangent of 0 is 0. Tangent of pi over 4 is 1. Tangent of negative pi over 4 is negative 1. And then as you get closer and closer to pi over 2, right, your denominator of that fraction gets smaller and smaller and closer to 0. So you swoosh up positive, swoosh up negative here. But because tangent repeats its values in quadrant 1 and quadrant 3, look at what the period is. And yes, your x-intercepts are point of inflections where tangent changes from concave down to concave up. What's your period? Right? The period of tangent repeats in between these fences. Now, I know those snakes look cubic, but they aren't cubic, right? Cubic functions grow without bound here on either side. These little snakes are trapped within the fences, and then you copy, paste, copy, paste, copy, paste. So your range is all real numbers, but the snakes repeat every pi. Cotangent is very, math joke time. Oh, look at my sinusoidal, right? Sunscreen. Look what happened. That's my tangent lines. Wah, wah. Cotangent has vertical asymptote everywhere sine is 0. X-intercepts everywhere, cosine is 0. A y-intercept, when you plug in 0 for x, cosine of 0 is 1. And sine of 0 is 0. 0 in a denominator is undefined. Right? You're going to kick these values out of the domain. Your range is the same. And yes, your period will end up being the same. So again, I'm going through these quickly because you did them last year. This should make sense that with a vertical asymptote at x equals 0, you certainly can't have a y-intercept. You have your x-intercept at the pi over 2's. Your vertical asymptotes are at the pi's. And the behavior is the opposite of tangent. You have those trapped snakes, but the snakes decrease in between the fences and are concave down to concave up to concave down. All right, old news. For cosecant, again, please try to think of it as a fraction. That will help you identify where your vertical asymptotes are. Everywhere sine is equal to 0. Sine is equal to 0 at the pi's. 0 pi, 1 pi, 2 pi, negative 1 pi, negative 2 pi. Yes, you need to label them with their equations. There aren't going to be any x-intercepts, right? Because for a fraction to be equal to 0, the numerator has to be equal to 0, and you can't make that numerator equal to 0. But sine does have maxes and mins. So I'm not plotting x-intercepts on cosecant. I'm plotting sine's x-intercepts because that's where I'm going to draw vertical asymptotes for cosecant. And then remember, sine x rises to 1, hits the sinusoidal axis, falls to negative 1, hits the sinusoidal axis, rises to 1, and repeats and repeats and repeats, right? So every sinusoidal hit becomes a vertical asymptote. But think again about the reciprocation, the flip. This is a flip of sine. What happens when you flip or reciprocate 1? I need to change colors because you still change 1. 1 is on both sine and it's reciprocal because the reciprocal of 1 is 1. Now reciprocate all of these red values, but remember you've kind of like cut the graph there. So reciprocate and swoosh. The reciprocal of negative 1 is negative 1. So what are you responsible for labeling? You are responsible for labeling the vertical asymptotes, which are all when sine x is equal to 0. And you are responsible for labeling the maxes and mins. So your vertical asymptotes are everywhere sine x is equal to 0. They need to be labeled. You have no x-intercepts. You have no y-intercepts because when you plug in 0 for y, for x, you get 1 over 0, which is undefined. Your domain comes from kicking out your vertical asymptotes. And what's your period this time? Is it changed? No, right? Your period is the same as sine, which is 2 pi. What's your range though? Look at the red range. The red range bounces back and forth between 1 and negative 1. Negative 1 and 1 being included. But what about the blue range? It's the flip, right? It's negative infinity to negative 1 included, and then positive 1 included to infinity. Right? Does that make sense? What was a maximum on sine becomes a minimum. What was a minimum on sine becomes a maximum on its reciprocal. So you need to label all of the vertical asymptotes, and you need to label the maxes and mins, which are no big deal because they're the maxes and mins on sine. The maxes and mins on sine turn into the mins and maxes on its reciprocal. Same exact thing for secant. Vertical asymptotes are where cosine is equal to 0. Maxes and mins on cosine, or the mins and maxes on its reciprocal. Fraction has 1 always in the numerator, so there's none of those. This time when you plug in 0 for x, you get 1 over cosine 0, which is 1 over 1. The period is the same as its reciprocal, cosine. The domain is kick all the pi over 2's out, and the range is the same as cosecant. Cosine looks like this. So if you can draw a cosine, you can draw a secant because you're going to draw vertical asymptotes through every sinusoidal hit. And you are going to take every max and make it a min, every min and make it a max, and then flip and swoosh. Flip and swoosh. Oh, that's terrible. Nicely done. Okay. Notice that just like sine and cosine, cosecant and secant are just shifts of one another. So some things that we did a little bit last year, but not an awful lot. We did ask you to evaluate secant, cosecant, but I could now say something like this. Solve secant x is equal to 2 over root 3, which means you have to inverse secant. Or, right? I'm going to put cosine back here for a second, at least on 0 to 2 pi. Let me just say let's just say I want you to only give me the solutions on 0 to 2 pi. So notice that if you think not secant, but think about its reciprocal friend, you're much more familiar with the reciprocal, right? 1 over cosine x is equal to 2 over root 3. You have an equal sign. Reciprocate both sides. Reciprocate the left, reciprocate the right. You know that. Who has a cosine of root 3 over t? You don't need any inverse things. Who has a cosine of root 3 over 2? Pi over 6. Pi over 6 has a cosine of 2 over root 3, but has a secant of 2 over root 3. I'm sorry, I wrote this wrong. 3 over 2, 2 over root 3. Also in quadrant 4, right? Crazy. So that's what this slide is. Look at this, copy that one down for a minute. That's exactly what we just did. Notice that I'm asking you for 0 to 2 pi. I don't think secant. I say to myself, self, that's really 1 over cosine of alpha. I don't have a calculator, so I need to reciprocate both sides and think, who has a cosine of root 3 over 2 positive on one trip around the unit circle? That's quadrant 1 and quadrant 4. And that's pi over 6 and 11 pi over 6. This one I would give you a calculator for. Be very careful. I am just asking for quadrant 1 values, which is nice because that's what your calculator is going to give you. There's no inverse secant button on your calculator. You need to think that's really 1 over cosine, and I'm going to reciprocate that to cosine, which means I have to reciprocate the other side. I will inverse cosine this on my calculator because I don't know what that is, and I get approximately 1.07-ish. So this is the actual only new topic that you didn't do last year. Notice the question only asked me to describe the transformation. It does not ask me to graph. Hint, I'm going to add that. But if you are just given this question, you just describe the transformations, and this is no big deal. Transformations are transformations, right? You've been doing that. We made you write those out for lines, and then quadratics and exponentials and blah, 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 blah. So what's happening, right? We have, since my sinusoidal axis is y equals 2, the whole graph has been shifted up 2 units. Since my phase shift is 3 pi over 4, my whole graph has been shifted right 3 pi over 4 units. Now I need to kind of talk about some sinusoidal stuff, right? Because we have b is equal to 4, which means there are 4 cycles in a distance of 2 pi. And we use b to get the period, which is 2 pi over 4, meaning that our period is pi over 2, which is the distance to complete one cycle. Since the amplitude did not change, you don't have to mention it. You only have to mention it if it changes. If it did change, you would talk about, oh, it's right, the distance from the sinusoidal axis to the max and mins is now blah. Okay. I am going to ask you to graph this, which we didn't last year. So to graph this, I'm actually not going to graph it at first. I'm going to graph that because I'm pretty good at cosine graphs. You can mess around with cosine graphs. I've practiced them a lot, right? And I made you practice them a lot. AAF this year, right? Assessed, quizzed, tested, right? Grouped, projected, whatever. You've done a lot of this. So I'm actually going to draw this graph. Now I do have to remember, so I have a sinusoidal axis at 2. I have an amplitude of 1. Oh, bother. Cosine is positive. The dilation factor is positive. So I'm going to start at a max, and I'm going to start at 3 pi over 4. Maybe here. And I'm going to start at a max. Where am I going to end? Right? Remember what our period was? Our period was pi over 2. So if I start at 3 pi over 4 and I add pi over 2, right? This is actually how many fourths? Isn't this 2 pi over 4? So I'm going to end at 5 pi over 4. Right? Add 2 pi over 4s to 3 pi over 4, and that's 5 pi over 4s. And I'm going to stretch this out. It's not, my scale is not going to be great, but you get it. So 3 comma 5 pi over 4 and 3 comma 3 pi over 4 are maxes on cosine. Then I'm going to hit the sinusoidal axis twice, and I'm going to hit the minimum in between. That's my cosine graph. My secant graph, though, is going to have a vertical asymptote through every sinusoidal hit. And what used to be a max is going to be a min. What used to be min is going to be a max. And the shape is going to go flip and swoosh, flip and swoosh, flip and swoosh. So I'm done with my graph, right? Just one, right? That's a period of 2 pi. I mean, one period. How do I get my other marks, right? How do I know where my sinusoidal hits were? My quarters. Pi over 2 divided by 4 is pi over 8. So you're going to take 3 pi over 4, which is really 6 pi over 8. You're going to take 6 pi over 8, and you're going to add 1 pi over 8. So this vertical asymptote is at x equals 7 pi over 8. This maximum on secant is at 8 pi over 8, comma, boundary. The next vertical asymptote is at 9 pi over 8. And then the next point is at 10 pi over 8, which is 5 pi over 4, which is a check for myself. Okay, so see how I used my prior knowledge and what I'm pretty good at to graph something I don't see a lot. You're not going to see secant and secant transformations a whole bunch, but you're going to see sine and cosine a lot. And you can build everybody from them.